my name is Joe Hicken. I'm head of policy for a startup based out of Somerville, Massachusetts called Sublime Systems. The company was incorporated in March of 2020. So the company is actually 3 years old now, a little over almost 3.5 years old now. And actually was founded via research conducted out of MIT. And so the company was spun out of foundational kind of lab-based academic research conducted by a luminary kind of in the climate tech space. His name is Professor Yetming Chang. If any of you are familiar with him, he's invented a number of energy storage solutions that have been spun out into companies that are now scaling products in the kind of the climate tech space. And he was partnered with Dr. Leah Ellis, who had received a very prestigious Canadian fellowship, the Banting Fellowship, which gave her 2 years of no strings attached funding to pursue research that was impactful for the planet. And so the two of them partnered together and applied their training in electrochemistry. So they're chemists by training. And cement is a chemical. Actually, it's not a clay. It's not like Play-Doh. It doesn't dry. It actually cures. So there's actually a chemical reaction. I'll talk a bit more about why that's important on this whole thing in just a moment. But the two of them were wondering how they might apply electrochemistry to another climate challenge. And so as inventors do, they stumbled into cement as a possible opportunity and learned that, in fact, they could use a different thermodynamic process to manufacture the material that results in the same concrete that we use in all of our infrastructure. So maybe taking a step back there, concrete is the most widely used man-made substance on planet Earth. It is, and in terms of substances writ large, the only thing that outpaces it is water in terms of our humanity's usage of this material. So it is literally in all of our roads and sidewalks and hospitals and schools. It is the fabric that constructs our modern world today. And it's been around for a very long time in some form or fashion. So the Romans used a version of concrete that clearly has lasted a couple thousand years. And the most recent iteration of it is called Portland cement, ordinary Portland cement. And the way that this cement is manufactured, cement is kind of like the glue that holds concrete together, right? So concrete it's got the pebbles, it's got sand, it's got what are called admixtures or chemical additives that modify the way that it behaves in application. And then the most important ingredient, which accounts for about a fourth of the weight, I think, by volume, is cement. And cement is manufactured today. It's actually a pretty simple mineral, limestone, which is abundant on planet Earth's crust. Calcium carbonate. It's an abundant mineral, and it has CO2 embodied in the rock. And so the way that cement is manufactured is they bake this rock to the temperatures of hot lava, literally, when it exits the earth, so about 1500 degrees Celsius. And when they do that, it changes the chemical composition of the stone. And so about half the weight of that stone, right? It's a solid rock. About half the weight gets converted into carbon dioxide and is vented into the atmosphere. And then the other half turns into this, it's kind of a magic material. It's a highly reactive material that, when exposed to water, undergoes a chemical reaction and hardens into a crystalline structure. It's called a calcium silicate hydrate. And so it kind of like binds together all the rock and stone and the sand and the gravel that makes concrete together, and it turns it basically back into stone again. It's a pretty cool material. So a lot of the emissions come from just like the decomposition of limestone itself. We're just taking CO2 that's been mineralized into limestone and re-releasing it into the atmosphere. And then the other large chunk of emissions comes from the use of fossil fuels in heating these massive furnaces to those high temperatures. And so this industry, it's, it's funny, there's a lot of criticism about contributors to the climate crisis. This industry is not really like, there's no bad guys in this industry. They're really the folks that are our builders, right? They're the ones that have enabled us to kind of live in the society that we live in today. It's just that there has been no other way to get calcium carbonate into the state that it needs to in order to behave and perform the way it does in concrete. You just have to chemically, thermodynamically bake it to those temperatures. So I've kind of issued the problem statement, and then some of you are already familiar with the size and scope of this, but it contributes about 8%, 7 or 8% of the globe's CO2 emissions come from cement manufacturing globally. So it's literally as much, it's actually more emissions than all passenger vehicles combined on planet Earth come from the manufacture of cement. So it's a pretty sizable chunk of emissions that are coming from the sector. Now, it's a tough emission source because it is intrinsic to like all of our systems and infrastructure, right? It's not like you can flip a switch and change overnight the manufacturing process that's built our modern world. It's very capital intensive. These factories have been built over many decades. In the number of them is actually kind of small. Like in the United States, there's about, I think there are 98 cement manufacturing facilities distributed across the United States. So it's not that many factories. It's just they're manufacturing a lot of this stuff, and in the manufacturing of a lot of this stuff contributes that CO2. Okay, so I talked a little bit about the problem. Then let's talk about the solution space. So there's a lot of cool tech emerging in cement decarbonization. So our perspective is that all of the solutions that are kind of emerging in the space need to like have support from the public sector and the government, and the general public writ large, right? Our specific solution is a carbon avoidance solution. So we're not relying on any sort of like creative accounting or net zero sort of strategies. We are fundamentally changing the way that cement is manufactured. And Yet and Lay are the inventors and invented this process, but fundamentally we're using an ambient temperature electrochemical process to extract the calcium and the silicates from raw materials, using renewable electricity. So it's all renewable power that's powering our reaction. And we're able to use, because we're using an extraction process that's not baking the material, we're able to use different feedstock for our cement. So we don't need to use limestone. And in fact, the company was originally founded to use limestone. And then we learned that we could actually process other calcium silicate rocks. And in other industrial wastes, which is actually pretty exciting too, right? So there's a kind of a circularity play here beyond just the carbon abatement. So through our electrochemical process, we're able to avoid about 90% of the emissions that come from the status quo process of manufacturing cement. What we can't, kind of the part of the equation that we really can't get at is the mining and grinding operations, the transport and logistics operations with handling the heavy materials. So there's a possibility down the road that we can, depending on our feedstock, we can get to that sort of like creative net negative sort of manufacturing. But for now, we're really proud about like a 90% reduction in manufacturing the material. So our process results in an ASTM. That's the, oh my goodness, actually, the acronym has flew out of my head. I think it's the Association for Standards and Materials Testing. It's TM, Testing and Materials International. Anyways, they set a bunch of standards across a number of different industries. They also set the standards for like cement and cement performance and the various features of concrete and does it, what test and what temperature and humidity and set times, and like it's a litany of sort of requirements. We meet the standard for performance of strength and durability. So we're fundamentally creating a material that is it's a unique manufacturing process that when it hydrates with that water, it results in that same concrete when it's hardened and dry. And actually, initial indications suggest that it might actually be more durable to certain environmental exposures like sulfates and internal corrosion, which is a problem with today's material, which we're really excited about, because we can not only bring a solution that like addresses the CO2 challenge, but also is potentially a stronger material. We'll we can revisit this conversation in 100 years. Okay, so it talked about a little bit about the problem, a little bit about the solution, and then let's talk about, okay, Sublime Systems, great technology. Why aren't we just like everywhere all of a sudden, all at once? And the reality, right, is that a startup like ours, there's this and this is kind of well established throughout technology maturity and development, and it's especially the case in the construction trades, where the volumes of material are just as relevant as the actual performance and the features of the product itself. So a good example of this is that a traditional ready mix concrete plant, these are, you've seen the spinny, a lot of people call them the cement trucks. They're actually concrete trucks because they've got, cement and the materials in them to the wet concrete. Those are, populated throughout the United States. There's, 10,000 or so of these plants, right, that are incorporating the cement. They consume, on the order of 20,000 tons of cement per year, right? They're pouring so much content and material. And so for them, from like a commercial standpoint, they're not really interested in engaging with new products unless it's something that they can rely on, a regular volume of material that's price competitive and doesn't squeeze their sort of like business model, right? A lot of these shops are family-owned businesses that have been passed down through generations. And so for a company like Sublime, what we need to do is not only mature the production of the material itself, but we need to produce it in such quantities that it's relevant for like the existing commercial marketplace to adopt it. And that's where policy comes in, right? That's where like federal policy and state policies really will drive the difference between this company scaling the way that cement companies traditionally scale, which is over decades. And you get that sort of like regular growth, kind of a linear growth pattern where you generate materials, you sell those materials, generate profit, reinvest that back in, and that cycle kind of like progresses pretty standard. Or in kind of aligned with our chief executive officer's vision of growing a company that has swift and massive impact. How do we scale this thing to manufacturing scale much faster? And so our federal policymakers, and actually, Linda, I'll send you this report and you can distribute it to the group after. But the Department of Energy actually issued a fantastic report recently called the Pathways to Commercial Liftoff Report for Low Carbon Cement. So it's a pretty good document. It talks more about the problem and less about policies and solutions to the space. But it's a really good sort of assembly about, hey, this is why this matters. This is the market dynamics. These are the solutions that we think are good bets. Electrochemical manufacturing of non-carbonate minerals, which is our technology, is included in the two sort of like bets that they're assessing as viable solutions in the near term. And so, okay, so let's talk about like the technical maturity curve, right? So there's this, they call it the Valley of Death. So we've got a pilot plant facility operating in Somerville, Massachusetts. We're manufacturing tons of cement, which is just delightful for a startup, but it's not commercially relevant volumes of material. So there is this sort of commercialization valley of death that we need to hop over, and some of that comes in the form of pursuing federal grants and support, and we're running after those opportunities with the Department of Energy. We think we got a really solid shot at getting their support, but that's kind of like That's an all eggs in one basket sort of approach to scaling massively. And so we are pursuing adjacent policies that kind of help de-risk the whole sort of industrial base. And by that, I mean the government, and by that it's federal government and state government, ends up purchasing more than half of the concrete that's used in this country every year. So as opposed to other sort of like market dynamics where government intervention can be kind of received a little skeptically, that like, oh, hey, you're kind of tipping the scales unfavorably, let the market forces kind of drive solutions here. It's a little bit of a different problem, and it's actually potentially easier because the government is the ultimate user of the concrete, of the majority of the concrete that's deployed. So we're trying to push for what are called advanced market commitments or structured offtakes for the federal government to essentially guarantee the purchase of large volumes of low carbon concrete from the marketplace that then can be used to justify what's called bankability. So these are, I don't know if any of you are in finance or were in finance, but fundamentally making it so that a traditional banker, a traditional investor who's going to, invest large sums of money to build factories, can assess that, hey, this is a very low risk from a commercial standpoint because the materials that they're going to manufacture are already bought. They're already committed to be purchased and taken down from the factory. And so we can invest money for the next 20 years and have a pretty reasonable rate of return on that. And there's no risk in us losing that investment, right? They're not venture capitalists. Bankers are, they're just looking for a solid rate of return. So there's advanced market commitments or structured offtakes and getting the government to participate in being, figuring out how to enter into those sorts of contracts. We know they want this material. They're just kind of, the bureaucracy is getting in their own way. So there are a lot of folks that want to just say, hey, we're ready, we want it. Let's just articulate that formally in a way that bankers feel comfortable with. And then the second policy that we're pushing for is the reality of the situation, especially with the Valley of Death, is that the price of carbon just isn't incorporated. And I know that you all have worked on the national level on a price of carbon. And that's not really politically tenable, but we've seen inklings of price on carbon that are industry specific. And you see a little bit of that in the 45Q IRA legislation that passed last summer that assesses like a credit, a tax credit. So it's not really pricing the carbon, but it's giving a credit to the people who are dealing with the carbon in a certain way. What we're interested in is pursuing a little bit more, maturing that concept a little bit more, specifically associated with low carbon cement and concrete. Maybe we could do low carbon construction materials, but it starts to get like a little bit wonky. How do you compare like, a ton of steel versus a ton of cement or concrete? Starts to, apples to apples gets a little funky there, but we could certainly explore it. But basically making it, pulling a play out of the solar and wind playbook where they've arrived at prominence and commercial viability through what it's called a production tax credit. So what that is it's a tax credit on the unit of production itself before the material has actually made it into the marketplace, so that the manufacturers and the producers of the material have lower risk of being able to kind of bring this thing into the marketplace and manage any sort of like lumpiness in offtakes or purchasing on the kind of the commercial side of the equation. And so for us, that would make the whole arrangement a lot more attractive, at least for like the near term, while we cross this valley of commercialization depth and get to that commercial scale, where future investors can say, oh, okay, we see like your cost of production might be a little bit high at your pre-commercial state, but we can help you get over that hump by bringing that, by lowering the unit price to a commercially competitive value, the way that solar and wind did it for the last couple of decades. So those are kind of two policy levers. I just throw that out there for like consideration and kind of a cogitation a little bit there. But I'll go ahead and I'll wrap up those thoughts there. I shared with you a little bit about Sublime Systems, the company, and the tech and the product, a little bit about policy. And I kind of skipped over the people part of the presentation, but happy to tell you all a little bit more about the awesome people that I work with too, but I've spent the last 20 minutes talking at you, so I'll take a little breather there, and would love to answer your questions.
So Joe, I want to ask you about the production tax credit, which is the second policy you mentioned. And when we talked earlier, we compared that to like a solar renewable energy credit. Like if somebody has a 6 kilowatt system on their roof, they get 6 solar renewable energy credits a year, and the utilities pay us for those. So, and that helps make the purchase of those solar panels much more affordable. And is that similar to what this production tax credit would be?
It's a very similar concept in the economics. The cement and concrete isn't really a consumer business, so you know you do have a concrete driveway, right, or a concrete foundation in your home, but the largest volumes of material are poured in like the foundations of structures and roads, and airstrips, etc. But the concept is somewhat similar in that as an individual, you're getting a tax credit that reduces your risk of installing this infrastructure on your home, where you're making it more affordable to take the risk of saying, hey, I'm going to pay for solar panels on my home. PACE would be another sort of like similar policy lever that was implemented successfully. I think that was passed by actually Senator Downing when he was in office, which tied the liability of that solar panel to the deed on the property, as opposed to a liability for the individual taking on the solar panel itself. So these sorts of things that really comes down to risk, right? It's like, what is your risk as a person or your risk as a company in interacting with a new material, a new supply chain, a new vendor? The economic risk is that's a great sort of example. It's a little like the mechanics are a little bit different, but the intent is the same.
So who would, with these, if there was advanced market commitments, who would own the factory that is making the cement, the low carbon cement? Would you need to have usual investors lined up and build that factory? And you could say, if you build it, the government will commit to purchase a certain amount over a period of time. What does rollout look like if you're rolling this out at a commercial level?
Yeah, Linda, that's a great question. So we're working through that right now. Our working hypothesis is that a company like ours needs to scale the materials and bring it to market so that the entire construction ecosystem has confidence in how does the material perform, both like what's the shelf life, and does the material perform like the wet concrete? Is it the same? Can you pump it through the same pumps? Does it finish the same way? Is the hardened final product the same that they can expect or better? Our lab scale materials are certainly indicating that we're passing all those green lights with flying colors, but there's enough fear, uncertainty, doubt about anything that's not this like old manufactured cement, that we feel like we just have to march ahead on scaling our own manufacturing facilities. But there is a openness to licensing the tech to all of the infrastructure folks that have been doing this business for many, many decades, right? Our core competence is on like a very specific part of the cement manufacturing process. There are folks who specialize in like grinding operations and like quarrying the raw materials. They've got all the distribution and logistics supply chain. So like So I guess to really simply answer your question is we will build as many plants as we need to own and operate, but there's certainly an openness to work with the folks that have been in this business for many, many years.
Joe, I understand you said that CO2 is embedded in limestone, right?
That what's embedded in limestone?
CO2, carbon dioxide.
That's right.
So how do you get out of the limestone?
How do we not use limestone as our raw material?
How do you get rid of the carbon dioxide?
That's great. Yeah, that's a great question. So we actually are not using limestone for our raw materials. We're actually using a different raw material. It's a calcium silicate rock that doesn't have any embedded CO2 in the material.
Oh, I see. Huh. And also, I'm surprised that the government is using about half of the cement produced in this country. I didn't even think even close to that. How come?
It's about 2/3. Well, actually, so here's an interesting thing. They're probably using more than half the cement that's produced in this country because we are a net importer of cement. About 20 to 25% of the cement that's used is actually imported from Greece and I think Portugal, maybe. So they're probably using more than half that's actually produced locally, and it's the vast majority of it's going to Department of Transportation's. So these are roadways for cars.
Wow.
And it's amazing that we import the cement from Greece and other, like we import granite from Italy and Spain. It's amazing that shipping it all the way from Greece to America is cheaper than producing it here.
Yeah, I think there's a number of dynamics that play into that one, but I think the largest is that our environmental protections, which are working, are basically prohibiting new construction of cement plants in the US. So there's a little bit of like a carbon accounting trick that's happening where we're not really producing locally and we just import.
The entire cement, the whole valuable cement is imported.
So, restate the question.
Are you saying that the entire volume of cement used in the United States is imported?
Oh, no, sorry. I'm saying that our environmental permitting process has slowed to a halt any new cement manufacturing using traditional processes, and so the country has augmented its cement deficit through imports.
So we have to purchase abroad what we can't make here, but
That's right.
It's a percentage of it, not.
It's 20 to 25%.
So let's say I own a cement factory and I have these huge kilns that heat it up to 1,500 degrees. And I wanted to start manufacturing using your process. Do I have to build a whole new factory, or are there retrofit? I mean, how would that work?
Yeah.
Maybe asking naive questions, but that's.
No, it's a prescient question, and it is the rub. So for the incumbents, there really is it's a tough challenge, and basically the options are bolt-on carbon capture, utilization, sequestration systems, which are of a similar sort of technology readiness level for application specifically to cement. It works in separating CO2 from methane when you pull it out of the earth. Flue gas is different, and I'm not a chemist, so I will wrap up the observation specifically on the chemistry of flue gas and carbon capture. So there's this retrofit option, which they think is about the same capital expenditure as building a brand new plant. And then it requires additional energy and additional electricity to power those systems. We also are capital intensive as well. So we don't use the kiln or the pre-calciner or like the preheating towers. We don't use the cooler infrastructure. We would plug into there. We have some interesting conversations with incumbents who have quarries that have run out of the useful life of the limestone. And so we could conceptually like plug in and extend the quarry life of the rocks that we can process. But it does require the build out of large scale manufacturing that is it's fundamentally a new build from a manufacturing standpoint.
Okay, so it's like it's not a retrofit. Is the carbon capture on the existing plants at all? Well, we have a certain skepticism about carbon capture anyway, but is that probably pushing the incumbents to want that to be the solution because that's the least disruptive to their existing operations?
It's interesting. I think the Global Cement and Concrete Association, they represent like all of the world's manufacturing. That's kind of their stated strategy to get to net zero by 2050. Is carbon capture is a strategy, but it's not the cost. I think the World Economic Forum estimated in partnership with there's this report that they published or will be publishing soon, which indicates that they think it's going to cost $1.4 trillion to retrofit the entire globe with carbon capture for cement. And that's assuming that it all works the way that we all hope it does.
Right, yeah.
And maybe it does, right? Like that's not, I'm not casting dispersions on that tech. It's just the economics matter a great deal. And the reality on all this, and that DOE report that I'll send Linda to you afterwards, it's very clear that if we're going to get ourselves out of this problem in cement and in many other hard to abate sectors, it's going to cost money. It's just,
Right.
It's just going to cost, resources. And
now,
Joe,
go ahead, Anatole.
are you familiar with the term light concrete? Is your technology makes concrete lighter?
yeah, actually, so this is, I don't know if you can see that well.
Yes.
So the brick of our concrete, and you can tell it's very white. So the albedo is very light. Now, you can't control the aggregates. So when you mix the stuff together, if you've got dirty sand or dirty rock, it'll just inherit it will inherit the properties of the materials it's mixed with. But our cement is much lighter than commercially available cement today. So there is this additional sort of like heat island effect, sort of like potentially aesthetic, architectural sort of like component to it. But we're marketing ourselves as a drop-in replacement for like mass cement. So like large pours at scale. So while we've got that like interesting facet to it, we don't really talk about that often because we don't want to be like lumped in with the small producers of that sort of architectural stuff.
Yeah, speaking of architecture, the old-fashioned concrete sweats and gets darker with time. Does your material do the same?
I'm not familiar with that dynamic, so I'd have to explore a little bit more. That's a good question.
So, is there general acceptance that the quality of the concrete that you manufacture is as good as what's out there? Because I think, we see with the big dig where some of the concrete was substandard and we're suffering terrible, is that one thing that people are comfortable with, that it's equal to or superior to the existing concrete?
Linda, the answer to that question is absolutely not. And so we're in the process, even though we meet strength and durability standards, We need to double down on getting the material in the hands of the architects, the engineers, the contractors, the ready-mix concrete producers. And so we're in that process right now. We're in that flow where we're getting the material out there for that adoption acceptance curve. I think the material will speak for itself. And so we'll have, yeah, I mean, yeah, it'll be one of those, like, you don't take Joe's word for it. Wait for like the press and the coverage of like our industry partners saying like, this is good stuff. We're really like excited about it. We have a state-of-the-art concrete testing lab in Somerville as well. So we've got our cement manufacturing plant, but we're also testing all the concrete through like the litany of it's actually pretty remarkable. Like, as a concrete is not my trade, so I was like, how hard can it be? It's concrete, right? It's, you know, it's like clay, you know, but it's not. It's really complex stuff. The chemistry is really every variable matters, and so we've got this whole really rigorous testing process. But at the end of the day, what's going to matter is, does the local ready mix producer in Boston say like, we like what Sublime Systems is doing? That'll really be the thing that moves the needle for acceptance.
Well, I have many questions, of course, as an architect, but one more is cementitious board. Is that how is that related to your lightweight concrete, cementitious board?
You're saying supplementary cementitious materials like slag and fly ash?
Yeah, they widely used now in siding the walls.
Right. It's
Finishing the walls.
right. It's a manufactured siding, right? Out of that has concrete in it,
which is actually cheaper than wood siding.
Oh, yes, yes, I know what you're talking about. I don't know enough about the application in that space to respond, I think, adequately.
I have a question for you, Joe. How long do you think it'll be before you get to commercial production?
Yeah, that's a good question. I want to answer it, but since I'm being recorded, and it might be distributed in a way that I can't control. Yeah, I mean, we are maybe the way to frame the response to that question in a satisfactory manner is to say we've got a very credible line on manufacturing at scale before architecture 2030 objectives are meaningful. So within that time horizon. Thank you, Millie, for that question, though.
Okay, so that's a little vague, but we'll take it. I can understand the caution. Do you think the product will ever be on the
hypothesis? But I think your observation there is an interesting one for us to consider from like a theory of change standpoint.
Right. Just most people don't realize the emissions from concrete, and most people don't realize that. So it's a problem that's not well understood by the public, I don't think.
It isn't. I mean, the amount of concrete that you might use in the foundation of your home, it's like, it's de minimis. It's so small relative to like, I think I won't shoot from the hip on size and scope, but it was like, well, maybe I will just for this conversation, but it was on the order of like your driveways. If you use traditional cement for your driveway, you're talking about the emissions of like driving your car for 3 months sort of thing. Like it's not, the volume is not there, right? It's not an individual consumer problem. It's a buildings and roads, massive infrastructure challenge. So from like a personal accountability standpoint, we can all take a sigh of relief that, like, you know, your driveway is not the problem, right? It's our societal needs and our connectivity that's the thing we have to solve for.
So do you know if there are any similar, if there's any similar research going on anywhere else in the world, or are you really the one and only?
100%. And in fact, there's a company, a small company out of California, or maybe it's Colorado,